Azure Storage Encryption automatically encrypts your data stored on Azure Managed Disk at rest by default when persisting it to the cloud. Azure Storage Encryption uses Server-Side Encryption to protect your data and to help you meet your organizational security and compliance commitments. Server-Side Encryption is a powerful mechanism to protect your data by ensuring that all data stored on Azure Managed Disk is encrypted at rest. While Azure automatically encrypts data using platform-managed keys, some organizations require more control over their encryption keys. Azure allows you to configure server-side encryption with customer-managed keys, allowing you to use your own keys stored in Azure Key Vault to encrypt the disk attached to your virtual machines. In this video, we will use the Azure portal to enable server-side encryption with customer-managed keys for an existing managed disk of a Windows VM. Hello everyone, I hope you are all doing well. I'm Manhar and welcome back to MSFT Webcast. Before you get started, make sure you have an Azure subscription, a Windows virtual machine and Azure Key Vault. A Key Vault must be created in your subscription to store the customer managed keys. Open your preferred web browser, navigate to portal.azure.com and sign in with your Azure account. Step 1. Set up Azure Key Vault. In the search bar at the top of the portal, type Key Vault. Under Services, select Key Vault. To create a new Key Vault, click on Create. Fill in the information needed to create the vault. This will include the Key Vault name and region, pricing tier, days to retain deleted vaults, etc. If you have multiple subscriptions, select the subscription in which you wanted to create the Key Vault. Choose the resource group you want to use or create a new one. For this example, I have already created a resource group named FreeVM-AG01. We will store this Key Vault in this resource group. Enter a unique name for the Key Vault. When creating the Key Vault instance, you must enable Soft Delete and Purge protection. Soft Delete ensures that the Key Vault retains a deleted key for a specified retention period, which is 90 days by default. Purge protection ensures that a deleted key cannot be permanently deleted until the retention period lapses. These settings protect you from losing data due to accidental deletion. These settings are mandatory when using a Key Vault for encrypting managed disk. Leave the other options at the default settings and then click Review plus Create. I'll cover all other options when I create a dedicated video on how to create and manage Azure Key Vault. Click Create to create the new Azure Key Vault. Deployment will take a few seconds. Please wait until it's complete. The Azure Key Vault has been created successfully. Click on Go to Resource to open it. Now that we have created the Azure Key Vault, we must add an Azure RBAC role to allow us to create new keys in the Azure Key Vault. Step 2. Add an Azure RBAC role. On the Key Vault overview page, click on Access Control. Click on Add and then select Add Role Assignment. From the list, select the role you want to assign. Select Key Vault Administrator role and click Next. Click on Select Members link. From the list, select the user, group or service principal. Select Manhar and again click on Select. Click on Review plus Assign. Again, click on Review plus Assign to assign the role. Wait for the confirmation notification to appear. After a few moments, the user will be assigned the role at the selected scope. The next step is to create a new key in the newly created Key Vault. Step 3. Create Customer Managed Key. Expand Objects and then click on Keys. You can either import your RSA keys to Key Vault or generate new RSA keys. Click on Generate/Import option. Because we are creating a new key, we will leave the Generate option selected. Enter a unique name for the key. Choose the key type and size based on your needs. For this example, we'll use the RSA key type with a key size of 4096. If you are using Windows 11, Windows Server 2022 or a newer OS, make sure to select an RSA key size of 3072 or larger. You can also configure the activation and expiration dates for this key. Make sure the newly created key is set to enabled. Leave the other options at the default settings and then click create. Wait for the confirmation message to appear. Your key is now created and ready to use. Step 4. Set up Disk Encryption Set. In the search bar at the top of the portal, type Disk Encryption Sets. Under Services, select Disk Encryption Sets. Click on Create button. Fill in the information needed to create the Disk Encryption Set. This will include the encryption type, encryption key, key vault, and other related settings. Select your resource group, name your encryption set, and select the same region as your key vault. Choose the resource group you want to use or create a new one. Enter a unique name for the Disk Encryption Set. Select the encryption type according to your organization's requirement. For this example, we will select encryption at rest with the customer managed keys. Once you create a disk encryption set with a particular encryption type, it cannot be changed. If you want to use different encryption type, you must create a new disk encryption set. Make sure select Azure Key Vault and key option is selected. Next, select the Azure Key Vault and key. Select the Key Vault and key we created earlier in this video. From the drop-down list, select the Azure Key Vault we just created. Select the Azure key from the Key Vault. Next, select the key version. If you want to enable automatic rotation of customer managed keys, select Auto Key Rotation. In this example, I'm not going to select it. Click on Review plus Create button. Wait for the validation check to complete. Click Create to create the new disk encryption set. Deployment will take a few seconds. Please wait until it's complete. The disk encryption set has been created successfully. Click on Go to Resource to open it. Navigate to the disk encryption set once it's deployed and select the displayed alert. At the top bar, click on the alert message to add the required permissions. This will grant your Key Vault permissions to the disk encryption set. Please wait until the confirmation notification appear. Now that we have created and set up our Key Vault and the disk encryption set, we can deploy a VM using the encryption. The VM deployment process is similar to the standard deployment process. The only differences are that we need to deploy the VM in the same region as our other resources, and we have to use a customer managed key. In this example, we will enable SSE with CMK on an existing disk of a Windows VM. Enabling disk encryption on any disk attached to a VM requires you to stop the VM. Step 4. Enable disk encryption on an existing disk. Go to the Azure homepage. In the recent resources list, select AWS-VM02, expand settings, and then click on disk. Check the encryption status of the OS disk. Currently, server-side encryption with a platform managed key is enabled on this operating system disk. Let's change the encryption type from platform managed key to customer managed key. Select the disk you want to encrypt. Expand settings and then click on encryption. Under key management, select your key vault and key in the drop-down list under customer managed keys. Once selected, click save to apply the changes. Please wait until the confirmation notification appears. We have successfully changed encryption type from platform managed key to customer managed key. Let's verify our configuration results. Go back to VM Overview page. Earlier, we had server-side encryption enabled with platform managed key. Click on refresh to see the updated information. We can verify that now server-side encryption with customer managed key is enabled for this operating system disk. Now you can start your VM. We have successfully enabled server-side encryption with customer managed keys for operating system disk in Azure. Customer managed keys have some limitations and restrictions. Let's discuss them. If this feature is enabled for a disk with incremental snapshots, it can't be disabled on that disk or its snapshots. A disk and all of its associated incremental snapshots must have the same disk encryption set. Disk encrypted with customer managed keys can only move to another resource group if the VM they are attached to is deallocated. Disk snapshots and images encrypted with customer managed keys can't be moved between subscription. Managed disks currently or previously encrypted using Azure Disk Encryption can't be encrypted using customer managed disk. These are the limitations and restrictions of customer managed keys. You have to create proper documentation and planning before using customer managed keys. That's all for this video on how to use the Azure portal to enable server-side encryption with customer managed keys for an existing managed disk of a Windows VM. I hope you found this video helpful and informative. If you have any questions or comments, feel free to leave them below. Don't forget to like and subscribe for more videos on Microsoft Azure and other Microsoft related topics. Thank you for watching, and I'll see you in the next video. Have a great day.